we have to look into stretching a spring. Here we have a spring and we're going to stretch it. We're going to apply a force downwards. There's the force. And it will extend. We will have an extension. What we're going to do is plot a graph of force against extension. This is the graph. Force on the horizontal axis, that's the thing we change, and extension will be on the vertical axis. So the research question is this: how does the force applied on the spring affect the extension? So we're going to apply different forces and see what the extension is. The first point is 0 force gives 0 extension. That's obvious. So we plot that one first. Then we're going to apply 2 newtons of force, and you see that the spring is extended. 2 newtons gives 0.5 meters extension. And then 4 newtons gives 1 meter of extension. And we'll plot that. Next, 6 newtons give 1.5 meters of extension, and so on. And the last one, when we apply 8 newtons, is extended by 2 meters. So this is the graph we have plotted. Now we need to draw a line of best fit through the points. The key features of this line are: 1, it is a straight line. Secondly, it goes through the origin. And if it's a straight line through the origin, we can say that the extension is proportional to the force. And what that means is that if you get a force, for example, 2 newtons, and the extension is 0.5 meters, if you double the force from 2 to 4, it means you're going to double the extension. If you triple the force, you're going to triple the extension. This is what proportionality means. Now we're going to find out how stiff that particular spring is by seeing how much force is needed to stretch it by 1 meter. So you look on the table. To stretch it by 1 meter, it takes 4 newtons. But we can use a formula to do that as well. So this is the graph. We can find out how stiff the spring is by seeing how much force is needed to stretch it by 1 meter. Now you know it takes 8 newtons to stretch it by 2 meters, so therefore it must take 4 newtons to stretch it by 1 meter. It's that simple. So the stiffness of the spring is 4 newtons per meter. We can also use the formula. The formula is F is equal to Kx. Now if F is equal to 8 newtons, X, which is extension, is 2 meters. We rearrange to make K, the stiffness factor, the subject, which is F divided by X, which is 8 divided by 2, gives a value of 4 newtons per meter. This is the stiffness factor of that spring. And it doesn't just work for springs. We want to find out the stiffness factor of, for example, Peppa Pig. Peppa Pig, what are you doing here? Oh dear, we've stretched Peppa Pig, and now Peppa Pig has an extension. We apply 20 newtons, and Peppa Pig is extended by 4 meters. So Peppa Pig is stretched by 4 meters with a force of 20 newtons. How much force is needed to stretch Peppa by 1 meter? So, in other words, what is the stiffness factor of Peppa Pig? F is equal to K times X. Let's put those values in. For F is 20 newtons, X is equal to 4 meters. We rearrange. K is equal to F divided by X, which is 20 divided by 4, which is 5 newtons per meter. So the stiffness factor of Peppa Pig is 5 newtons per meter. But what do you get when you stretch poor Peppa Pig? You get pulled pork. Delicious. I wonder what's for lunch.